So we have two types of exponential functions. We have a growth function and a decay function. And to tell that, we look at the equation of an exponential function, and we're going to look at the b value. That is called a growth factor. Okay, now if you remember, if b was big, like bigger than 1, then the picture of it would be that it's small on the left and then it gets really big on the right. This is called a growth. For obvious reasons, it's getting bigger. If b was between 0 and 1, so a fraction between 0 and 1, you'll remember that it starts big on the left and then it gets smaller on the right. This is called a decay. Okay, so there's many things in life that are growths and decays. One thing I think of right away for decay is when you get a shot. When you get a shot, they put some kind of antibiotic into your body or antivirus thing, and as time goes on, it decays, but it never actually leaves your body. Even though a flu shot is over in a year, it doesn't mean the flu shot's completely gone. There's this microscopic little amount in your body at all times, and it just gets so small that it doesn't help anymore. So let's look at another example of a growth. So let's say that gas prices go up 20% every year. Okay, this is just made up, although it feels like it. Okay, now, if I'm looking at this, I'm trying to figure out what is my equation going to be. So remember, we have y equals a times b to the x. Now, a is how much you start with. So let's just say we start back to when I was a kid. When I was a kid, it was 99 cents. Okay? Now, the next number is going to be the next year, and it has to go up by 20%. But what are you going to multiply by to make it go up by 20%? If I multiplied by 0.2, or 20%, if I took that, I would get 0.198. It didn't go up to this isn't going to be 0.198. That would be silly. Okay? So I have to figure out, what am I going to multiply by? What is this one number going to be? I know most of the time we say, well, take that and add it onto the 99. The problem is we don't have that to represent there. We need one number to put there, and it's not going to be 0.2. And so when I add that to 99 cents, what I'm really adding it to is the 100% that you originally had, and then this is the 20% that we just found. So technically we're talking about getting 120%. So I want to multiply this by 1.2. Remember, that's moving it from 120%. If I move the decimal over 2 places, it'd be 1.2. So that's going to be that number right there, the 1.2. Now, if you want to be technical about how you're really supposed to write this, a lot of times they write it y equals a times 1 plus r to the x. And this is pretty much exactly the same thing. The difference is that 1 right there, and that's just taking care of our 100% that we were talking about. And then it adds in the rate, so it was increasing by 20%, so we'd put a 0.2 there. So that's how we get our 1.2. Okay, so then our equation should be y equals 99 cents times 1.2 to the x. And that would be our answer for that one, or our equation at least. Our other kind is our exponential decay. And let's say that an example would be that high school dropout rates, I don't know where this came from, they decrease by 10% each year. Okay, so if I look at that, let's say the high school dropout rate at one time was, this is a great decrease, let's say it was 50%. So in year 0, I suppose it would be, it would be 50%. No, sorry, I'm being stupid. Okay, so let's say that, there was 5,242 people that dropped out at the first year that we were looking at it. Now, to figure out the next year, we need to multiply by some number. Now, I really want to multiply by 0.1, right, which is 10%. 10% is 0.1. But if I do that, then I'm going to come up with 524.2 people. Well, that's how many people are not going to drop out anymore. That's not what this number is going to be. This number is going to be my 5,242 minus the 524.2. So I don't want to multiply by 0.1. What I want to do is I want to multiply by what I have left. Now what we're doing here is we're taking 100% minus 10%. And so technically we're keeping 90%. So what I want to do is I want to multiply by 0.9. Is going to be my multiplier number, my loopty number. So then when I look at my equation, it's going to be y equals, and I'm going to start with my starting point, and then I'm going to take it times 0.9 to the x. Now, if you want to get technical, the book will tell you that y equals a times 1 minus r to the x, and that's exactly what we did here. We took 100, which is 1, minus the rate, which was 10, and it gave us the 90%, or the 0.9 that we're going to multiply by. Now, you can also figure out the equation from a table, because if you have a table, you first want to figure out what are you multiplying by. That's always going to be your first thing. Well, if you're multiplying. Sometimes you're not multiplying. And if you're not multiplying, it's not exponential. But if you are multiplying, you just first have to identify what number you're multiplying by. Now, sometimes it's obvious like this one. If there's other times that it's not obvious, what you're going to want to do is take your second one and divide it by your one before it. And that'll give you the number that you're multiplying by. So again, the second one divided by the one before it. And so now I can write y equals, and I can put 2 to the x. But what I'm missing now is that number in front there. And that's my number when x equals 0. So I'm going to have to go backwards to figure this out. I'm going to have to figure out what times 2 gives me 6, and this problem's pretty easy. It's going to be 3. Otherwise, you could say, well, if I take 6 divided by 2, so do the exact opposite, since I'm going backwards, you would get your 3. And that would be the equation from your table.